Alright, so what I want to go over today is a calculus problem. So the problem is as follows. What is the limit of the following if it exists? So you're taking the limit as x goes to negative 3, as x approaches negative 3 from the left hand side. This is what this negative means right here. It means it's approaching 3 from the left hand side of x squared plus 14x plus 45 divided by x plus 3. So we want to find out what this limit is. So what a limit is basically is the output of your function. So we have this function right here, and we have an x that's approaching a number, and we want to figure out what is the output giving us in this function. So basically, okay, if we have x, we want to figure out what is y. If x is a function, or if y is a function of x, what is y giving us when x is approaching this limit? So, for example, let's just say the function looks like this right here. So we have this x-axis and we have this y-axis, and this is our function f of x. So the limit is saying, okay, let's just imagine that x is approaching negative 3, so that's going to be right here. What is this function right here returning us? So what is the y value, or what is the output given that x is approaching this input? And we're coming from the left hand side. So we're coming from here and we're approaching negative 3. So to compute limits, there's multiple ways you can go about it. So the first step would always be just to substitute what x is equal to into your function and then see if we can get an output, or see if we can get a limit. So if I plug in x equals negative 3, in the denominator, I'm going to get negative 3 plus 3, which is equal to 0. Anytime you try to divide something by 0, it's going to be undefined. So we can't use, and this is what's called the direct substitution method yet, because we get undefined when we plug in x, and we substitute in negative 3 for x in this case. So then I think, okay, where are the other ways we can compute the limit? The next thing you can think of is, okay, can I factor this out and maybe something cancels? So I look at the numerator and I see that it can be factored, so it can change into x plus 9 and x plus 5, and then we have that all over x plus 3. So how do I factor that out? 9 times 9 is 45, x times x is x squared, and then 9x plus 5x is 14x. So that's how it factors out. But nothing really cancels out in this case, because if I plug in x equals negative 3, I'm still going to get undefined at the bottom. So that method doesn't work either. So now, another way you can think of this is, okay, let's take some points around x as it's approaching negative 3 from the left hand side, and then plug them into this function and see what we're getting. Based off of the points that we plug in, we can make a conclusion about the limit as x goes to negative 3 from the left hand side. Okay, so the first number I can take is, let's just say that x is going to approach negative 3.1. Now, after I do that and I compute that limit, I want to compare it to when x approaches a number that's a little closer to negative 3. So then we're going to plug in x is going to approach negative 3.01. So that's a little bit closer to our ultimate limit that we want to compute, which is x approaching negative 3. So the first thing we're going to do is we're going to take the limit as x approaches negative 3.1, and then so let's just write this as it's factored, so x plus 9 and x plus 5, because it's going to be easier to plug in, over x plus 3. So now I can do a direct substitution. I can plug in negative 3.1 in for x and then compute this limit. So I'm going to get, this is going to be equal to negative 3.1 plus 9, and times negative 3.1 plus 5 divided by negative 3.1 plus 3 is just going to give you negative 0.1. So after doing your calculations, you should get that the limit is equal to negative 112.1. So just based off of this limit, we can't really say anything until we compare it to a number that's a little bit closer to negative 3. So we're going to plug in negative 3.01 and see what we get. And then we're going to compare those two limits, and then we can ultimately make a conclusion about the limit as x approaches negative 3. So this is how the problem looks. Now we're just going to substitute in negative 3.01 in for x. So it's going to be negative 3.01 plus 9. And then you have negative 3.01 plus 5. That's going to be over negative 3.01 plus 3 is just going to be negative 0.01. And then that limit is going to be equal to, so it should be 5.99 times 1.99 over negative 0.01. And that should be equal to, which is going to be equal to negative, so you got 1,192.01. So that's a limit as x approaches negative 3.01. Okay, so the first thing we did is we took the limit as x approaches negative 3.1 of the function, and we got negative 112.1. Then we plugged in a number that's a little bit closer to 3, negative 3. So we plugged in, we want the limit as x approaches negative 3.01. We compute that. That was negative 1,192.01. So what can we say about the limit as x approaches negative 3 from the left-hand side? We can say that that limit is going to be equal to negative infinity. How can we conclude that? Okay, so we want to find the limit as x approaches 3 from the from the left-hand side, negative 3 from the left-hand side. So first we took 3.1, negative 3.1. We got this number. Now we're taking a number that's a little bit closer to negative 3, and we get this number. This limit jumps by, it's more than 100. So then we can conclude that this limit is going to be negative infinity, because it's going to jump again. It's going to become even more negative as we take the limit when x approaches negative 3. So that's going to be your answer, is going to be negative infinity. And there it goes right there. And that's how you solve this problem.